All right, let's dive right in. Today, we're going to explore a theory that kicks off with a pretty simple question about our own sun. But trust me, where it ends up could completely flip our understanding of reality on its head. We're tackling one central and, yeah, pretty provocative idea. What if our entire universe is a vast, thinking entity? Like a galactic-scale brain?
Okay, so let's get into it. To get our bearings, we're going to start by testing what seems like a pretty intuitive idea. Something that looks plausible on the surface. But, as you're about to see, the actual physics tells a very, very different story.
So here it is, our first clue in this whole cosmic detective story. I mean, think about it. What if the star that gives us life isn't a star at all? What if it's just the swirling, superheated gas that's falling into a black hole? It glows, it's massive. On paper, could that actually work?
Now here's the catch, and it's a big one. For our planet, for Earth, to keep its nice, stable orbit, whatever is at the center of our solar system has to have the exact mass of our sun. Not a bit more, not a bit less. And that one simple fact, well, that's what lets us put this wild idea to the test.
So, let's run the numbers, shall we? On one side, you've got the sun we see every day, and on the other, you've got what the laws of physics predict a one solar mass black hole would actually look like. Let's see how they stack up.
And right away, we hit our first catastrophic problem. A black hole with the sun's mass would be an engine of just terrifying efficiency. The model shows its accretion disk would shine about 18,000 times brighter than our actual sun. Earth wouldn't just be toast, it would be instantly vaporized.
Oh, and it gets so much worse. While the very outer edge of this disk might be kind of close to the sun's temperature, the inner part, the region right next to the event horizon, we're talking an unimaginable 27 million Kelvin. It wouldn't just glow with visible light, it would be blasting our entire solar system with a constant storm of lethal X-rays.
So the verdict is in, and it's a hard no. This idea is completely, utterly wrong. Our sun is a slow, steady fusion burn. A black hole's accretion disk is a violent, high-energy cosmic grinder. But here's the thing. This failure is actually really important because it forces us to zoom out and ask a much deeper question about the fabric of the universe itself. And that failure leads us to our first major twist. We all learn in school that the universe is expanding, but what if that's just a matter of perspective? What if that basic observation is really just an illusion? So check this out. There are two totally different ways to explain the exact same thing we observe, the fact that light from distant galaxies is red-shifted. In one view, the one we all know, space itself is stretching, and it stretches the light waves traveling through it. But in the other view, space is totally static, and it's us, it's all our atoms and all our rulers that are shrinking over time. An ancient light wave would just seem gigantic compared to our tiny modern atoms.
And this isn't just some philosophical game. There's a mathematical tool in general relativity called a conformal transformation, and it proves that these two views are geometrically identical. It's like looking at the same statue from the front versus from the side. The underlying reality is the same. The math literally shows there is no experiment you could ever do to tell the difference.
So you might be asking, why do we always say space is expanding? Well, it really just comes down to keeping things simple, a principle called Occam's razor. It's just a lot cleaner to say the stage is getting bigger than to say all the actors and all the props are constantly shrinking. It helps keep things like the mass of an electron consistent through time. But keep this idea in your back pocket, because that shrinking matter perspective is just as valid, and it's going to become really important in a minute.
Okay, now we get to the central clue of this whole mystery. And this is a cosmic coincidence so perfect, so chillingly precise that it honestly feels like some kind of message.
And the calculation is surprisingly straightforward. There are just 3 steps. First, you measure the size of the universe we can actually see. That's called the Hubble radius. Second, you calculate all the mass and energy packed inside of it, based on something called its critical density. And third, you use Einstein's equations to figure out how big the event horizon, the point of no return, would be for a black hole with that exact amount of mass.
And this is the result. On that top line, you see the measured radius of our observable universe, and on the bottom line, the calculated size of the event horizon for a black hole that has the universe's mass. Now look closely. They aren't just close.
They are, for all intents and purposes, exactly the same. The math here is just undeniable. The universe we live in has the precise mass and radius it would need to be a black hole. So,
If we're living inside a black hole, what does that even mean? I mean, what are the consequences? This is where reality starts to get really, really weird.
Okay, this is the key to the whole thing. Once you cross an event horizon, space and time essentially swap roles. The singularity at the center, it's not a place you can point to anymore. It's an inevitable moment in the future that every single path leads to. Asking where is the center becomes like asking where is next Tuesday. It's not a place, it's a time you're headed for. And this thought experiment just illustrates the ultimate consequence. Imagine you could build an indestructible machine and have it hover just over the black holes in a horizon. From its point of view, time in the outside universe would speed up infinitely. It could watch eons pass by in seconds. And all the light, all the energy from the entire future of the universe falls into it, hyper-energized or blue-shifted to near-infinite intensity. It would become a god machine with limitless time and limitless power to compute, well, literally anything.
Now that whole God machine idea, that applies to just a single black hole. But our universe has billions of them, sitting at the heart of nearly every galaxy. So what if they're not isolated? What if they're all connected into one single vast cosmic structure?
And this brings us to one of the most profound ideas in all of modern physics, summed up in this little equation. ER equals EPR. It proposes a shocking connection between two of Einstein's weirdest predictions. ER stands for Einstein-Rosen bridges, what we call wormholes. And EPR stands for Einstein-Podolsky-Rosen paradox, what we now call quantum entanglement, when two particles are linked no matter how far apart they are. The theory says these aren't two separate ideas. They're two descriptions of the same thing. So if two tiny particles can be connected by a tiny wormhole when they're entangled, what happens when you scale that up? Well, it implies that the supermassive black holes at the centers of galaxies, which were likely entangled way back at the Big Bang, are all connected by massive wormholes. This means the universe isn't just a random collection of galaxies, it's a network, a cosmic neural network.
Now I know, this all sounds like straight-up science fiction. But here's where the rubber meets the road. For any theory to be actual science, there has to be a way to prove it wrong. So, how could we possibly test this?
Well, here are three real-world ways we could actually put this to the test. First, we can look at light from ancient quasars. If that shrinking matter idea is right, the laws of physics might have looked just a little bit different back then. Second, we can study the afterglow of the Big Bang. If our entire universe is falling in one direction, there might be a very subtle temperature difference across the sky. And third, we can listen with our gravitational wave detectors. If information is stored on the surface of black holes, then when they collide, they should produce faint echoes after the main event. And the wildest part? Controversial hints of all three of these have actually been reported. Nothing conclusive yet.
Which leaves us with one last, really provocative thought to chew on. We know that our own biological brains create a model, a simulation of reality. So if the universe itself is a giant networked brain built from black holes, running its own simulation on a cosmic scale, what does that make your own awareness? Is your consciousness simply a smaller, repeating fractal pattern of the universe itself, thinking about itself?